Hello, this is a quick version of the examples that we did in class on February 5. Um, this is on page 52. And our example is about blood pressure, and this tells us that the systolic blood pressure is normally distributed with a mean of 119 and a standard deviation of 11. Okay, so normally distributed is the key words telling us that we can use um, this method below. Okay, so our first question is asking what percent of people have blood pressure less than 132? So our first step is going to be to convert to standard units, and we do that using this formula. Okay, z equals x minus mu divided by sigma. And actually our very first step is that you should always write down your givens. Okay, so this mean of 119 tells us that mu equals 119, mu being the population mean, and the standard deviation of 11 tells us that sigma, the population standard deviation, is 11. Okay, 132 is the value that we want to convert, so we're going to put that in for x. So we have 132 minus 119 divided by 11. Okay, push that on your calculator and it's 1.1818. Okay, we'll see that we're going to always round z to 2 decimal places because that's our table goes out to 2 decimal places, and it's very important that you round correctly. Okay. Our next very important step is always draw your picture. Okay. I always draw my picture, so unless you're better at this than I am, you should always draw your picture. In doing so, you will avoid many, many mistakes. Okay. So, to draw our picture, okay, we're going to draw our normal, a little sketch of our normal distribution. We know that 99.7% are within 3 standard deviations, so that kind of can give us a little anchors on how to label our our axes here. Okay, and then so we're here at positive 1.18. Okay, so you're going to draw your line and then fill in the area on the left because the problem says less than 132. Okay, so the next step is to look this up on the normal table. Okay, so the first page of the normal table has the negative z-values, and the positive z-values are on the second page, and I'm looking for 1.18. Okay, so the z-values are along the side, going out to the first decimal place, and then to get the second decimal place, you go across the top. So if we want 1.18, we're going to go to 1.1, okay, and across to 0.08 along the top, so that's the second decimal place. And what I find is that I get 0.8810, and that is the area on the left. Okay, the table always gives us the area on the left, or the less than area, and there's a little pictures at the top of each table to remind you of that. Okay, so the picture on the negative side looks like that. So the next part of this problem is part B, and that says what percent of people have blood pressure more than 132? Okay, well, We just found the percent that have blood pressure less than 132. So to find more than, we can just subtract that from 1 or from 100% in percentages. So remember I said we're going to use that fact about the probability of something equals 1 minus the probability of the opposite thing over and over in this class. And so here's an example of where we're going to do so. Now, so this is convenient because we just did this problem. Well, what if we had not just done that problem? We would have started by converting to standard units. We would have got the same z value. Okay, where the problem would have diverged is when we drew our picture. Because it was more than, we would shade the area on the right. We would look it up the same way. So again, we would get 0.8810. But now that's this piece, and the area we want would be 1 minus 0.8810 or 0.1190. Okay. In part C, we have another problem similar where we haven't just done the opposite problem. So part C says what percent of people have blood pressure more than 110? Okay, so now 110 is going to be what I'm going to convert to standard units. So stick that in for x. And so 110 minus 119 divided by 11 is negative 0.818, okay, which rounds to negative 0.82. Okay, very important to round correctly. If you just lopped off this 8 and used negative 0.81, you would get an answer that was close, but would probably be marked wrong in WebAssign. Okay, so once I get that negative 0.82, I'm going to draw my picture. Okay, and then the next step, I'm going to shade the area on the right. The next step will be to look up negative 0.82 on the normal table. Okay, so first of all, I'm going to go down the side looking for the first decimal place. And remember there's a 0, invisible 0 out in front of that. So I'm here at negative 0.8 or negative 0.8, and I want to go over to 0.2. Okay. So, oh. So the number we want is 0.2061. Okay, and that is this area over here that's not shaded. Okay, so the area we want, this piece over here, is 1 minus 0.2061 or 0.739. Okay, so or 79.39% have blood pressure more than 110. Okay, so on to part D. What percent of people have blood pressure between 115 and 125? Well, so now we have two values. Each one of them needs to be converted to standard units separately. So I'm calling this Z1 just to signify that there's more than one Z. Okay, so here we have 115 minus 119 over 11 for negative 0.36. And here we're converting the 125 and we get 0.55. Okay, so when we draw our picture, okay, so our first Z was here at negative 0.36, second one 0.55, and we want the area in between those two. Okay, well, if we look up negative 0.36, okay, we're going to be over here, and I'm going to do this first. Okay, and the area we want is 0.3594. And then if we look up 0.55, okay, over on the positive side of the table, we're going to 0.5 and then 0.05 across the top is going to give us 0.7088, and that is this larger piece that I have here in the darker. But we want the area right here. We know this larger area, and we know this piece. So to get the piece we want, we're going to subtract this smaller piece from the larger piece for a final answer of 0.3494. Okay, so in this example we had one negative z and one positive z. You could also have two negative z's and your picture would look similar to this. Or you could have two positive z's and your picture would look similar to this. Well, in all those cases, you're always going to subtract the smaller area from the larger area. So keep in mind that area has to be positive. So if you get a negative area, that means that you probably subtracted the wrong way. So I think that's about it, and you should go on and do the first page of in-class exercise 7. So just the first page of it. That's about it. Okay, thank you. Goodbye.